Good afternoon. My name is北科大-段畯and we are team number 33. We're going to be presenting about the application and study of YOLO algorithms for real-time CCTV recognition in Taiwan. Our main goal for this project is to use a convolutional neural network, such as YOLO, and Taiwan's real-time CCTV live feed to detect and classify the following vehicles. We've got sedans, SUV, pickup trucks, auto trucks, bus, taxis, and cars. YOLO, You Only Look Once, is a popular real-time object detection algorithm that stands out for its speed and accuracy. It's widely used in computer vision tasks to identify and locate objects within an image or video frame. The YOLO algorithm divides an input image into a grid and applies a single neural network to the entire image, predicting the bounding boxes and class probabilities directly. Here's a simplified explanation of how it works. So we got the image grids, the bounding box predictions, class predictions, confidence scores. The confidence scores is what YOLO assigns to each predicting bounding box, indicating the algorithm confidence that the box contains an object, and the accuracy of predicted class probabilities. And we got also non-maximum suppression, which helps to eliminate duplicate or overlapping detections. YOLO uses non-maximum suppression to remove redundant bounding boxes based on their intersection, over union, overlap, and retains the box with the highest confidence score. So the strength of YOLO lies in its ability to process images in real time, as it avoids the need for a sliding window or region proposal mechanism. This is the YOLO timeline. So YOLO, for our project, we decided to use YOLO V8, which was released this year in 2023. So what's new in YOLO V8? So YOLO V8 is the newest state-of-the-art YOLO model that can be used for object detection, image classification, and instance segmentation tasks. YOLO V8 was developed by Ultralytics, who also created the influential and industry-defining YOLO V5 model. So a few of the reasons why we consider YOLO V8 is that YOLO V8 has better accuracy than previous YOLO models. It supports object detection, instance segmentation, and image classification. And you can train YOLO V8 faster than the other two-state object detection models. Okay, so like I said earlier, this is YOLO V8 supports object detection, instance segmentation, and image classification. So this is YOLO network architecture and design. So this is the YOLO model. So the YOLO model has a backbone, which is a series of convolutional layers. As you can see, you can pull the pixels down at different resolution sizes, and then those features are passed through a neck, where they are pulled together and then they're put into a head, which is used to make the detections, and the detections are based on loss metrics. So the traditional YOLO has a box loss and class loss and an objectness loss. YOLO V8 does a number of iterations on improving the loss function at the end and the way these boxes are detected. So YOLO also have new convolutions and changes. So it replaces the C3 model with a C2F model. It replaces the first 6x6 convolution with 3x3 convolution in the backbone. It deletes two convolutions, number 10 and number 14 in the YOLO V5 model. Replace the first 1x1 convolution with 3x3 convolution in the bottleneck. And finally, it used decouple head and delete the objectness branch. YOLO V8 is also an anchor-free model. This means it predicts directly the center of an object instead of the offset from a known anchor box. So when comparing the performance of different YOLO models on the COCO dataset, we want to compare performance, speed, and compute cost. So for performance, we have the mean average precision. For speed, we have the speed of the inference, and for compute, we got the size of the model in flops and parameters. So YOLO V8, the YOLO V8M model achieved a performance of 50% on the COCO dataset, whereas the largest model, YOLO V8X, achieved a 54% with more than double the number of parameters. So YOLO V8's high accuracy and performance make it a strong contender for any computer vision project.
Hello everyone, my name is 段畯茗. Next, I will introduce the implement of YOLO. For our project goal, we have 3 goals in this project. The first goal is to explore the working and application of the YOLO algorithm in real-time traffic surveillance. And the second goal is to learn the diverse applicability of YOLO in areas. And the third goal is to compare different versions of the YOLO algorithm. For the dataset preparation, we choose two highways, including elevated sections, tunnel sections, and gate sections to collect the photographs. And finally, we collected 774 images, and then we label them with 7 label types: sedan, SUV, pickup truck, auto truck, bus, taxi, and car. For training dataset, we use Python and OpenCV on Google Colab and choose 4 models in YOLO to train our dataset, such as YOLO V5 and YOLO V5X, YOLO V8 and YOLO V8X. And comparison graph for different models shows as follows. Look at this picture. It can be seen that the performance of the model YOLO V8X is best in our dataset, and we can see the training result of the model YOLO V8X. It can be seen that the types of the vehicles can be detected clearly. However, we want to strengthen our performance of the models. Therefore, we increase our dataset to 914 images, integrating a variety of high-quality vehicle photos. These new images cover a wide range of vehicle types and perspectives, offering a different learning source for our model. The primary aims of this expansion was to improve the accuracy of our model by exposing it to more varied and high-quality data. And comparison graph for different datasets is shown as follows. Look at this graph. It can be seen that the performance of the new dataset is better than old dataset. And we can see the demo video. For this video, it can be seen that the types of the vehicles can be detected clearly. Finally, for the conclusion, after experimenting with the YOLO algorithm, we concluded it can work for pretty much scenario, and the algorithm can be easily adapted for any need. For the project, it is great for surveillance and monitoring big space where a single person might fail to focus on many things at once. For continuous improvement and optimization, we have 3 directions. The first direction is consistency and standardization in data labeling, and the second direction is diverse and high-quality data is superior to inconsistent data, and the third direction is model adjustment and optimization. Thank you for your listening.